Hello there ladies and gentlemen, and welcome to today's video. And today we're going to be taking a quick look at this A1466 MacBook Air with an 820-3437 motherboard and the issues that we had with this one. This was a water damaged board. Now then, I filmed this in sections going back probably January sometime actually, so it's going back a little bit. Turns out that when we actually looked over the board, I needed to order a few parts in for it, and then between actually sort of recording the initial part of this video and I get it fixed, it was fairly time constrained, so unfortunately didn't have time to go through the repair live, but I will go through what we did to fix it, and so we'll go through exactly the process that we went through to diagnose the issues and to repair the faults, and we'll show you the thing working at the end again. So this basically is just a quick thank you to everyone for the 5k subscribers. This is the first video I've put up since we hit that milestone the other week, so I do thank you. We will do a proper 5k sub video hopefully this week sometime if I can get a chance. I basically just wanted to tack this into the front of this video just to say thank you to all you guys who are out there and follow me. And like I said, for those of you who've stuck with me since the beginning, an extra big thank you to you guys, because I certainly wouldn't be here without you now. To be honest, let's face it, I won't be here without any of you. So thank you, and here's to the next milestone, whatever that may be, and hopefully we can get there fairly quickly. So like I said, we'll do a proper video at some point in the future. I'll try and, I don't know, we'll see if we've got something we can give away. That'd be quite nice, wouldn't it, to mark the occasion. But for now, sit back, relax, and enjoy as we take a look through this MacBook Air. So thank you for watching, boys and girls. Thanks for the 5k, and here we go. Right, hello ladies and gentlemen, and welcome to today's video. And today we're going to be taking a look at this MacBook Air. I believe it's 2013 MacBook Air. This particular one is an A1466, and it's got a rather interesting problem. So I had a phone call a few weeks ago from a guy who was having a look at this MacBook, and essentially what he was saying is it had a bit of liquid damage on it, and he couldn't actually get it to run off the charge. So it was running off the battery, but it wasn't running off the charger. It wouldn't charge, it wouldn't do anything. It was dead as a doornail, but it would run fine off the battery. So we said, okay, that's absolutely fine. So he sent us a couple of pictures, and there was a fair bit of liquid damage on the DCing board. Okay, but he said otherwise. He says the other board kind of looks alright. He said the biggest part of the liquid's gone on what looks to be the smaller board at the side of the main board. So, well, that's the DCing board. So if you're not getting any power from your charger, but it's running fine from your battery, and the liquid's on your DCing board, then replace your DCing board. So he did that, and then we got a phone call a couple of days later. He said, I've done that, but I've still got a bit of an issue. So what we ended up doing was saying, send it in, we'll happily take a look for you. And that is exactly what this guy's done. So we've got it here, and funnily enough, it's got a few different symptoms these days. So the battery, unfortunately, is flat. It's on 1%. So you're thinking, well, how can you tell it's on 1% if it's flat? Aha. Well, because this machine seems to have developed, obviously liquid damage is liquid damage, and it's fairly funky stuff. So it would appear that in the time that it's been with him and it's come to me, come to myself, it would appear that something has either corroded a little bit more, or something's just died a bit of a death since, because actually the machine does take power from a charger. Now you don't get any charging lights, so there's no light on the MagSafe at all. We've charged a different MagSafe as well, but the machine does power on when mains power is applied to it. So it powers on, but you don't get any light. Okay, but the machine does power on. It does post, it does chime, and the machine will go into OS, because when you hold a light up to the display, you do get the little Apple logo, and indeed it does boot into the OS, and you can, with a bright light on the display, you can see that it's actually got 1%. Now it does have a little charging symbol on the battery, but the battery doesn't appear to charge. As I say, there's no light on the charger, so that's hardly surprising, but it is running off mains power. So, what else doesn't work on there? I have no idea. The keyboard appears to type, because the cursor's in the enter password box, and it does type. The power button itself doesn't seem to turn the machine off. I'm not sure it's got trackpad. The buttons do respond, but I can't see a mouse pointer on the display. So it looks to have a few problems. So let's see. I don't know if you'll be able to see this because unfortunately I haven't got a light in here. There's the desk lamp. You might see. That's how I noticed it was running off the backlight, but whether the camera's sensitive enough to pick that up, I don't know. The only flash I've really got bright enough is on the phone camera, which I'm currently using to record this thing. But hopefully you'll hear it chime if I get close enough. So because it's an Air and the battery's completely flat, it powers off, on, off, on, off, on. Bit of a strange one. Don't know why they do it, but they do. Any sec, we should get chime. So you can see the backlight does come up and then fades back out. And then you can, well, there is a little Apple logo there. I'm not sure if you can see that. Probably not on the camera, to be fair. Probably the reflection is doing for it. But we'll see if we can get it close enough for you to kind of see it, maybe. No. If I hold it up to the light. If I hold it up. Oh, it's gone off now. There is stuff on the display, but unfortunately you can't see it. So there is stuff there. You'll just have to take my word for it. Unfortunately, the camera's not sensitive enough to pick that up. And as I say, I haven't got a flashlight to put on the display apart from the one that's on the phone camera. But it is there, and there are things on the screen. So the buttons do click, and like I say, they do work the machine up. I don't think there's any trackpad response. There's no light on the charger. Although there's a power symbol on the battery, it doesn't appear to be charging the battery. So yes, there's a few issues on here. So let's get to work and let's see if we can at least see some problems and see if we can find what might be wrong with this machine. Alright, okay then, ladies and gentlemen. So we've got our board out of our MacBook now, and we've got the schematic loaded up for it here. So the board we've actually got is an 820-3437A. So we've got the schematic for the 820-3437 loaded up. Now then, there are two very different sort of configurations of this board. There's an A and a B. The only difference being is that A has 4 gigs of RAM, B has 8. So we've got a 4 gig iteration of this particular MacBook Air. So we've got the board out and on our desk now, and we're just going to take a quick look under the scope at the moment, just to see if we can see where the problematic areas might be. Okay, so we're going to go over and see if we can see where the sort of messy, horrible crap is. So there's a little bit down on this back edge here of this. I presume it's the SD card slot, and you can see there that it don't look great. But SD card at the moment I'm interested in because of course I have no backlight and I have no power to my particular machine. So we have a little bit of crap there on this IC and the little resistor next to it. See if we can get some more focus in there. So it looks nice for you. Okay, so you can see we've got a little bit of something going on there. Not entirely sure what the IC does as yet. So I'm just trying to have a look around the side of the microscope to see if I can see where all the horribleness is. So you can see there's some red probe points and things like that. So when you see, you know, probe points that are sort of this colour here, you know, they're a little bit corroded. You can see we can scratch them and they go shiny. That's because they've had something spilt on them, probably water, something like that. That component there in the middle is a crystal, but again, you know, not too worried about anything like that for now. So you can see there's some red probe points there as well, but you know, there's nothing there particularly around them as such. So we've got some bits and pieces over here. Oh, that looks relatively clean, albeit you can see there's some more red probe points. So our area down here, this is our SMC chip, and everything there looks okay. Nothing there looks particularly nasty, particularly manky, which is always useful. So, I mean, we're not, well, there's a couple of probe points there on the back of that, you see, which look a bit odd, but you know, we're not terribly worried about those. At the end of the day, the machine sort of comes up and it does work to an extent. So of course we know it boots and we know it'll go into the OS. We just have an issue where it doesn't charge and where of course we have no backlight. So our machine actually does boot and it does post and everything else. So we must have basic power rails. So we must have things like PP bus G3 hot, we must have PP3V42, PP5V S0, we must have PP3V3 S0, things like that. So we know we must have those because, of course, you know, our machine works, our fan spins, our machine does boot, it goes into OS. We're just missing some fundamental sort of bits and pieces. So we're missing a light off our charger, so we can't get any charge into the battery at the moment. So that's probably the one thing that's going to be the first thing we need to solve, so we can actually get some charge into the machine. And then, of course, we need to be able to see what we're doing with the machine, so we need to get the backlight working. And then from there, we can sort of troubleshoot, you know. Once we've got a working charger, we can get some power into the machine, and we can actually see what we're doing. From that point, we can maybe run ASD and just see if that pulls up any sort of silly behaviour that's going on with any sensors or, you know, anything else that might not be working, any particular circuits that are knackered. You know, so, but the first thing to do really is just run a visual check over this board. Now, the back side of this board, apart from those a few bits and pieces we pointed out earlier, actually looks fairly clean. So we're just going to flip our board over and we'll have a look, see what's what down here. So this is the other side now. So this is the bottom side of that SD card connector, and we can see here there is a little bit of, well, there's some red probe points around there. So that GL3219 there is USB, so we may have some issues with the USB on this machine at some point, but again, don't give a toss about USB at the moment because we've got more pressing issues to take care of. That capacitor there, little polytank capacitor there, that has some water next to it, but it is next to it. It's not actually on the actual capacitor itself or its contacts, so that should be okay. But obviously we will clean this off before we've finished with it. We're not going to leave it there because it has potential to corrode. We can see that's the LCD backlight connector. The actual connector in the chassis looks absolutely fine, so there's no corrosion, nothing burnt there, which might be causing us issues. We can see the connector itself there looks nice and clean. There's no sort of corrosion marks around it. There's nothing inside it at all. That's all looking rather cool. The backlight fuse there, it never blows. Trust me, it never blows. And I have actually checked it off camera, and again, it's reading fine, even though we've got no backlight. Now then, this does look particularly interesting. So you've got those two big capacitors here, and then of course you have this little, what looks like a diode. There's a red probe point down the back of this this coil here, which will be the backlight boost coil, I would imagine. And then you've got this little capacitor here and a test point there. Those look rather nasty, so that's probably gonna want replacing, I shouldn't wonder. So we're probably gonna have to replace those at the very least, I should think. So what else have we got on here then? Let's see what else we've got. So at the top end there, so this is the Wi-Fi card. Top end there we have that little IC. See if we can get some focus on it. There you go. Not sure what that IC does, to be honest, but you know, little probe point there. It's had some water around it, so we'll have a look. So I think the first thing to do, to be honest, is just go through and make this the obvious water damage good. You know, just touch a few of these points up and see what we get. Now then, that's interesting as well. Look at that. So cap there, look at that resistor there, that looks horrible. That resistor looks horrible. That looks knackered. Loads of water around it, loads of corrosion. Little IC there, looks okay. Red probes there, some corroded probes there, look. Give it a quick scratch. Give that a quick scrape there. Don't know what that does, we can have a look at that. And then of course, what else have we got here? The LPC port connector there, which Apple uses to reprogram SMCs and things like that. It's very nice for them because of course they can do it. Not so nice for us because they don't give us the kit. And I'll tell you what's really fudged up about that. I would like to use a slightly stronger word, but you never know who's watching, really, you know. I have some young viewers somewhere, and the word I would like to use there isn't really appropriate. But You know, essentially, if we try to we can buy the SMC chips new, but without programming. So if we want to replace an SMC, we have to take one off a scrap board, because of course as soon as you try to dump anything from the SMCs, it erases itself. So even an existing SMC, you try to dump it, it erases itself, uses the programming, which is great. There's only one reason for that. That's because Apple don't want anybody like myself fiddling with these things. There's a little bit of crap there on that connector, but so yeah, that, to be honest, right, that's these test connectors and things like that. You might think that they're not up to much, but believe me, corrosion in those, you don't want it. So to be honest, you could probably just remove that. Ooh, what's down here? What's that? What's that? Oh god, that looks like ass. No idea what that does. Coil there though, so that looks interesting. It'll be power for something. It'll be power circuit for something. Those are capacitors, you see. That looks like a little sort of FET, if you like. Be interesting to see what that actually does. Then I think that's the processor just under there. We've got some various bits and pieces along the back. Some little red probes there, but it generally looks tidy enough under here. There's a couple of coils in there, and small power regulation stuff around here, fan connector, and some other bits and pieces. So as you can see there, and then just for shits and giggles, if we have a look there, look for the water sensor pad there, nice and red, next to the LCD backlight connector. So yeah, we've definitely got a few bits and pieces on here. So I think the first thing we want to sort of definitely check is to see why we get no. I mean, at the end of the day, right? We can worry about USB later. We can worry about all these bits and pieces. For essential purposes, our machine is up and it does run. Okay, so that's cool. So we know we're in a basic state that we need to be in. But of course, with no charger, we can't get any sort of charging power to the battery, which we need to look at. That's probably first thing. Once we can get some power into the machine, and we can, then we can worry about being able to see what we can actually do, because we need to see the display to be able to work out. Then we can log in, we can try and get by and see what's working, what's not. Then we can run ASD and things like that and see if anything else is completely fucked up. But I think sort of like the first plan of action is to try and sort of get some charger power into this machine, take a look and see what's going on with backlight, clean up the obvious sort of water damage, and then see what we get, see where we go from there. Because like I said, just getting rid of some of this corrosion and some of these horrible bits might just work for us. So join us back in a sec, boys and girls, and we'll get to work and we'll take a look through some voltage readings, and we'll see if we can get any life back in this old girl. Right then, ladies and gentlemen, unfortunately we were stuck for a little bit of time there with that one, and I didn't have time to actually go over the full repair. I had to order a couple of bits and pieces in for this board, so it was done over a couple of days, and unfortunately, like I say, on the day I actually fitted the parts that were required, we were a little bit stuck for time. But that said, we will go over what we did and how we came to the conclusions that we did, and then we'll show you the working machine at the end. So what we did was, we had several issues. If you remember, we had an issue whereby it would power from the charger, but it wouldn't charge the battery, and apparently when we got the machine, apparently it would run from the battery fine, but once the charger was connected, the machine would power off. And apparently, so he could use the machine by all accounts, and of course when we got it and we got it on the desk, we saw that in fact the machine would power from the charger. There was no light on the charger, but the charger would power the machine. It wouldn't charge the battery, nor would it run from the battery, because as soon as we disconnected the power, it would just die. Now the battery was always showing at 1%. It would, it wasn't actually charging the battery, but it would run from power, but it wouldn't run from the battery itself. And we also had no backlight on the display. So let's go over then what we did. So we showed you the problematic areas on the board, and we'll probably cut some images in, the various affected bits and pieces that we saw. Just to show you exactly what we did and annotate those up a little bit, just so we're not working completely blind here. Anyway, so what we did was we realised that we had an issue with our battery. Okay. So that essentially, so what we had to do is we had to fix the issue with the light on the charger, because we were getting no charge to the battery. We weren't running from the battery, but the battery was reportedly, 1%. Is it really going to run from the battery, or is it just going to turn off? So the first thing to do is actually get some charge into the battery to determine whether the battery was the issue or the MacBook. So we had to fix the one-wire circuit. So how does a one-wire circuit work in a MacBook Air? Well, if you don't know, it actually runs from a data line, and the data line we're looking for is called sys_1wire. And we'll just find it in the schematic, because of course the motherboard we were working on was an 820-3437. It's a mid-2013 MacBook Air even. So let's just have a look here. So we can see that indeed we do have sys1wire showing up, and it's showing up as part of this chip here. This chip here, which is U5000. So LM4 FSX AH5BB. And for those of you who don't know, that is actually the SMC, or the System Management Controller. So you can see all these data lines coming in, out, in, out, in, out, in, out. The bi-directional ones there, look, which basically means it's a two-way communication data line. And you can see here we have this one here, an input here from sys1wire, which goes into the SMC. And you'll see a lot of these data lines here are actually labelled SMC_ something or other. So our SMC manages a big part of the hardware and power lines and everything, power rails and everything else that goes to various bits and pieces of our MacBook Air motherboard. And it works in tandem with the PCH and things like that to actually let the machine do what it does. And in this particular instance, of course, sys1wire is coming into the SMC. So if it goes into the SMC, where does it come from? So let's carry on searching through here, and we can see here this connector here, J9500, labelled as a critical connector. Sys1wire is a bi-directional line. So for those of you who don't know, J9500 is actually the connector which goes between the MacBook Air's motherboard and the DC inboard. And the DC inboard, of course, is where our MagSafe charger plugs in. So on the older machines, of course, we actually had the one-wire circuit integrated into the motherboard, and the adapter itself is just on a fly lead, out to the side, and everything comes into the motherboard and is managed on there. But on this particular instance, it's actually all done and controlled and managed on a separate board, which is a little DC inboard, which is what we were reported as having the most water damage on there. So we had a look, and the guy had already changed the DC inboard. So that, we were getting power into the mainboard. We could see that our machine was running from the mainboard. We weren't getting anything on the charger. So of course it could be one of two things. It could be another bad DC inboard, but that's unlikely. So what we actually could do is we could change it for a known good one, but we didn't have to do that. What we actually realised is that there is a flex lead which hooks onto this J9500 and links the two boards together. And what we actually noticed was that there was a heavy degree of corrosion underneath that little ribbon. And if we can get a photo of it later, we will. But there's actually a water indicator on that, and that's bright red. We have actually cleaned the connector up a little bit just to see if we could rescue it, but the pins actually inside the connector do look a little bit black and a bit nasty and a bit corroded. And the thing is, even if you do get continuity on a meter between 2 points, the thing is that any sort of corrosion will introduce resistance and capacitance on that line, and with it being a data line and a rather critical one, any sort of resistance or capacitance on that line will actually corrupt the signal and will cause our SMC. Although technically the two things can talk, the two things won't understand each other because the signal's being interfered with. So that is one reason you may get no lights on your charger. So what we did is we actually replaced that ribbon with a new part, and all of a sudden we were getting a light on our charger, which is very good. So if we have a look where that actually comes from as well, so that's the test point, we're not really interested in that. So that's this one wire. So let's have a look at the battery, because this could also be an issue, of course, is if you've got no charger. So if we had replaced that ribbon and we still weren't getting anything, of course, you have this thing here, which is This is the actual communication between the SMC, the system management controller, the battery charger and the battery. And what has to happen here is we have to have a data line which connects all three of these things so that the SMC can tell the battery charger to charge the battery, and once it's full the SMC can tell the battery charger to stop charging the battery. And also the battery needs to report to the SMC its power levels, its percentage levels, its its usage, so the amount of current it's actually pulling through the battery, so that the SMC can interpret the charge level left in the battery, so it knows whether to tell the charging circuit to charge it, and it can also determine how long left that the battery is going to last at the current sort of workload of the machine, if you like. So it's quite a critical thing. So as we can see here, this PP3V42 G3 hot is the G3 hot, so it's an always on persistent power rail of 3.42 volts, and that comes across these two little resistors here, and this R5380 and R5381, and these things here are called pull-up resistors. So they're 2k ohm resistors, rated for 1/20th of a watt, and basically what these little things do is these create a data line, and the way they do that is you connect the one side, so the first pins, pin 1, to a power source, which in our case is PP3V42 G3 hot, and we connect the other side to where we want the data line to be, so in this case in between these components. And essentially what happens is each one of these components will short this side of these resistors to ground every so often, and what that does is that causes pulses. So we have 3.42 volts normally, and then whenever one of these wants to talk, it just shorts that portion of the data line to ground. So what you actually end up with is a pulse of 3.42 volts, a pulse of 0, pulse of 3.42 volts, pulse of 0. And essentially what that creates is on and off, or ones and zeros, and it allows digital binary communication between all three of those components, and they can all talk to each other. It's very, very clever. But what happens is if we're missing PP3V42 G3 hot, so if we're missing that power rail, then of course we aren't going to get this. But our machine was running, it was booting into OS, so we knew we could rule this one out, because if we didn't have PP3V42 G3 hot, our machine simply wouldn't run. So we could discount this as being an issue. But if you've got a completely dead machine, yours doesn't turn on, and you're getting no light on the charger, and you've replaced the DC inboard, and you've replaced the flex, and you're still not getting anything, then it could be down to the fact that your SMC can't see your battery charger or your battery. So that's one thing to look out for. But in our case, we could discount that. We did check these resistors as well anyway, just to make sure, and they were 2k, both of them, so they were absolutely fine. So U7100, of course, we were talking about our charging circuit, and we did have a little bit of corrosion around there. We did clean that up, and everything was a-okay over there. Just for sort of completion, we did replace it with a new unit. Like I said, there was a little tiny bit of corrosion around that area, so best just to make sure, really, best to be safe than sorry. So we replaced that anyway, even though the other one was fine, but you don't want to mess with corrosion, really. So for the sake of what these were, a couple of quid, we just replaced it. So anyway, that got the thing charging again. But what about backlight? What about backlight? Okay, so the second issue we had with this particular machine was a problem with the LCD backlight, and yeah, so we're going to go through what we did there and how we worked it out. So on page 56 of this particular schematic is where we'll find the details for the backlight circuit, and it's this particular thing here that we were interested in, and it's this little U7701, which is the LP8550 LED Driver IC. And what this does is this takes the voltage coming in and boosts it up, and then sticks it out the other end at a much higher voltage that we need to run the backlight, because as I'm sure most of you are probably aware, backlights in LCDs and LEDs and everything else actually do take quite a bit of oomph to get going. So in this particular case, we are taking this PPVin SO SW LCD backlight, which is generated from PPBus G3 hot, which is about 8.6 volts on this board, and we are converting it up to something like 50 volts here to PPHV, which is high voltage S0 SW LCD backlight, and then that goes to our backlight, and of course gives us, well, helps to give us a nice image on our LCD display. So this U7701 here is essentially a DC to DC boost circuit, And without going into it too much, and to be honest I'm not really qualified to do so, but to sort of like simplify it, and it might be oversimplifying it a little bit, but essentially what happens is we take this PPVin SOSW LCD backlight. So like I say, it comes in about 8.6 volts, and it goes through this coil, and then from there essentially it goes through this diode, through these capacitors and out there. Now what this little IC does, U7701, is it boosts that voltage from the 8.62 to the 50 volts that we need. And the way that it does that is by using these two outputs here, this little switching circuit here, SW0 and SW1, and then it monitors what's coming out of that circuit just after the diode here, down A5, ball A5 under the chip, which is the feedback pin. And essentially what it does, and like I say, the actual scientifics of it, probably oversimplifying it slightly, but what happens is that when this switch is turned off, it actually causes a build-up of charge in the inductor here. It creates a magnetic field, and then once the switch opens, that field is destroyed. It basically switches the polarity and it throws everything out this way at a much higher level of voltage through this diode, and then it charges these capacitors at a much higher level of voltage than it had coming in. So it's probably very oversimplified there, to be honest with you, but that's roughly how it works. Essentially think about it like driving down the motorway in your car and slamming the brakes on. You know, the car stops, but you still go forward, don't you? It's your seatbelt that stops you going through the window. It's a similar sort of thing. You know, it's the potential and the energy all gets thrown with a much greater intent than it did beforehand, and that's essentially how this works. It goes to these capacitors where the voltage is charged, and if you switch it on and off fast enough, essentially that voltage stays constant, and yeah, everyone's out the other side, and that's why we get PPHV SOSW LCD backlight. So in our particular instance then, to actually deduce that this was faulty because we ended up replacing this this LED backlight IC, essentially you've got a couple of things to look for. So you've got voltage into the chip, so of course that comes from PP3V3SO into pin C4. You have PP5VSO, which goes into D1 and C1. So those are the power supplies, the voltage supplies for the IC. And then you've also got these couple of signals here. So you've got a PPVin SOSW backlight that comes in here, which then becomes the backlight enable signal. So you need that to actually tell the U7701 to turn on. And you've also got the pulse width modulation signal, the PWM signal as well, which is quite important. Now in our case we had signals coming into that area of the board. Now the only way you can really tell that, aside from test points, is to actually remove the IC and give this a prod and a poke underneath with the multimeter probes, which is a bit of a pain. But anyway, what happened is a good way to actually deduce whether the fault is actually to take a diode measurement reading of the output of this IC. So what can commonly happen is, to be honest, most people here will say that this inductor here is bad. You know, it always seems to be the case. Every time you get an LCD backlight issue on a MacBook, it always seems to be that whenever you read anything on the internet, people say, "Oh, replace the coil, replace the coil." I think I know of one instance where it's actually been the coil, and it wasn't even one that I had looked at. It was a video from my mate Lewis Rossman, who had one eventually, but he's done hundreds of these things, and like he says, it's never the coil, and I've never seen it be the coil on the ones that I've looked at. So don't believe that one. Usually it is down to a couple of things. So what you can have, usually more often than not, is it's a bad IC here. Now what can also happen is, you can have this diode go out, you can have this feedback via here. So this little pathway here from the front side of this diode here to the ball underneath this IC. There's a via that goes to the pad that this ball connects to, A5. That often burns, and then you're running link wires underneath the IC back out here and replacing the IC. So it's not very fun, but But what we do is we take a reading of the output in diode mode on the multimeter, So red probe on ground and black probe on the output, and measure it, and that will give you a reading. Now on our particular case, our reading gave us a reading of about 0.216. 0.216 is usually indicative of a failure of this IC. So it's quite a good idea to build up a database, a spreadsheet of values. So say one from a working board, one with a blown feedback via and stuff like that, and just measure the resistance of the circuit. And actually what you'll get then is you'll get a very good idea as to quickly where the issue in that circuit lies before you even sort of start, if you like. It's a good way of getting a tip, a bit of a clue as to where your problem lies before you begin sort of diagnosing a lot of this stuff. So that's quite cool. The other thing, of course, to make sure is that you've got voltage coming in on PP3V3SO and PP5VSO, because of course if you've no power getting to the chip's never going to turn on, you're never going to get any boost. Again, likewise, if you're missing this, PPVin SOSW LCD backlight, this backlight enable signal here is never going to tell the chip to turn on. So again, you're never going to get any boost there. If this feedback via is blown, as we said earlier on, then what will happen is the chip doesn't know what it's actually doing. So it uses the feedback via to actually monitor the output of this circuit. And of course, from there it can tell whether it needs to boost more, boost less, to keep that voltage constant. If that via and that ball is blown and missing, then of course it has no way of telling exactly what it's doing. It can't provide feedback to itself, so it shuts down output and you get no boost. So it's just bits and pieces like that that are fairly common on here. So that's what we did. Like I said, we had a reading of about 0.216 if I remember rightly, which told us that we needed to replace our U7701. We placed a new U7701 chip on there, and our backlight began to work again. So that was that then, really, ladies and gentlemen. In a nutshell, that's how we repaired our issues on our MacBook. So it's a good job I made notes of these at the time, because like I say, it has been a little while since fixing that machine and getting this video out there, but it seemed a good one to finish off, seeing as we had most of the stuff rushed in, and it just needed the explanation tarting up a little bit at the end there. So hopefully you found that pretty useful, ladies and gentlemen. As of course, if you've any questions, pop them in the comments below and we'll try to get round to them. So without further ado, I do believe I have a video somewhere of the thing working after testing, so hopefully I can find that, and if I can, I'll stick it in at the end and we'll go from there. So take a look at that now if we can. Right, okay, and basically the end result is this. So this is the MacBook here, and we are just we've plugged the charger in, but there's no power to the charger at the moment, so we'll just plug that in a sec. I'm just going to turn the lights off on here. So that you can hopefully see the light a little bit better. So I'm just going to power on. Now then, the battery is fully charged at the moment, so you will see a green light on the charger. And if we power the machine on, you'll notice we get the Apple logo, and we're going to boot into the OS. So that's it, ladies and gentlemen. Basically, that's how we came to the conclusions we did, and we ended up fixing this machine. So thanks for watching. I hope you've found that somewhat useful. It's a shame we couldn't go through the repair as we were doing it, but like I say, we were just restricted for time. But yeah, as I say, thanks for watching. Hopefully you found that useful, and hopefully you've learnt something. If you have indeed found it useful, then it'd be appreciated if you could comment, rate, like and subscribe to the channel. We do have a lot more of this sort of stuff coming up, and we have over 50 videos on there now of Apple MacBook, games consoles, PlayStation 4s, Xbox Ones, all that sort of stuff, plus a few other little bits and pieces, which, if you're new to the channel, you might very well want to check out. So thanks for watching, and I will see you on the next one. Many thanks for watching then, ladies and gentlemen. Hopefully you've enjoyed this video. If you have, then why not check out these recommendations below. Also, please remember to comment, rate, and of course subscribe to the channel if you found this useful. We've plenty more content on there, and there's lots more to come.